Well, welcome to the video for 4.2 day 1. We're going to be looking at the unit circle, and this is for Math 126. And if you took Algebra 2 Honors last year, you have some experience with the unit circle. If you've not seen this before, it'll be your first time kind of looking at things through this lens, but you'll get to see all of the development in this lesson. We're actually going to spend 2 days kind of on this topic. So, what a unit circle is, I think, first of all, a lot of times students don't know what the word unit means. Unit in general means one. A unit circle is a circle with a radius of 1. What we're going to do is we're going to take that circle and we're going to put it on a coordinate system. And then we're going to explore a couple values on that circle and the coordinates of a couple different points. But before we do that, let's just kind of get a reminder of the ratios with 30, 60, 90 triangles and 45, 45, 90 triangles, because those are going to be values that we're going to use on our unit circle. So let's say I have a 30, 60, 90 triangle and the hypotenuse is 1. We want to find the length of each leg. Now, if possible, if you kind of already remember your ratios, pause the video and try to do exploration A and B on your own. But if not, I'll go ahead and go through it now. Well, the pattern of the sides is 1, root 3, and 2, where the 2 is the hypotenuse and 1 is the side opposite the 30. You might notice that instead of using a 2 in the hypotenuse position, we're using a 1. So all of the side lengths are essentially cut in half. All of the side lengths are just half the length the side was for kind of our base triangle. So x is root 3 over 2 and y is 1/2. And when we're finding the sine and the cosine, as a reminder, we're using like opposite over hypotenuse and so forth. So for the sine of 30, opposite over hypotenuse is 1/2 over 1. Well, we just won't write the over 1. In fact, what we're going to find is since that hypotenuse is 1, it doesn't become significant for the sine at all. The sine ends up just equaling the opposite when we have that hypotenuse is 1. Cosine would be the adjacent over hypotenuse, and that would be just root 3 over 2 over 1, but we won't write the over 1. And again, the hypotenuse is just 1, so it becomes insignificant. If we use the sine of 60, its opposite over the hypotenuse, its opposite is root 3 over 2. The hypotenuse is 1. The cosine of 60 is its adjacent side over the hypotenuse, which is 1/2 over 1. We've already seen before that the sine of an angle and the cosine of its complement are the same measure. And that's true in any triangle. The sine of an angle is going to, any acute angle, I guess I should say, is equal to the cosine of the complement of that angle. Well, we're going to repeat this now with the 30, 60, 90 triangle. So the pattern of sides with the, with the 45, 45, 90 triangle is 1, 1, root 2. So this time the hypotenuse is root 2. Instead of root 2, the hypotenuse is 1. So really, to kind of work backwards, the legs are the hypotenuse divided by root 2. To undo that, we're going to divide by root 2 and rationalize that. And what we find out is each leg is root 2 over 2. These should be the same because this is an isosceles triangle. The sine is then the opposite over the hypotenuse. And that would be root 2 over 2 over 1. I won't write the over 1. Same thing, where the hypotenuse is going to be 1. And cosine is adjacent over hypotenuse, which is another root 2 over 2 over 1. And like before, the sine of 45 will be the same as the cosine of its complement, which is also 45. So those are the same. So now what we're going to do is we're going to look at a circle with a radius of 1. And we want to find the coordinates of point A. Well, point A would be found by moving over a certain amount and moving up a certain amount. Well, moving over would be what we had found earlier for x, which is root 3 over 2. And moving up would be what we had found earlier in that triangle for y, which is 1/2. So that's the coordinates of point A, just from this triangle. And so if we compare this with the values of the sine and cosine of 30, what we'll notice is that the cosine of 30 is the x value, and the y coordinate of point A is the sine of 30. Let's do the same type of thing, but this time we're going to look at a 45, 45, 90 triangle. We're going to put it on the unit circle. Remember, unit means 1. And so the reason we could fit this on here is in a unit circle, the radius is 1. Well, that ends up being the hypotenuse of this right triangle. So we had found earlier that each of these side lengths were root 2 over 2. So point B is at root 2 over 2, comma, root 2 over 2. Now these values are the same, but if we kind of connect with what we did in exploration C, what we're going to find is that x is going to be the cosine of the angle, in this case 45, and y will be the sine of that angle. And those are in degrees. So the unit circle is a circle that has a radius of 1. And so anytime that we're looking at this circle and we're trying to find out some of the information, we can actually use the coordinates of a point. So let's say I've got some point A, and we've got some angle that I'll name theta, and that angle could be various angles. And point A is x comma y. And really, we could drop a little hypotenuse here and be looking at a right triangle. Now, because the radius of this circle is 1, this would be x and this would be y. And we could use the Pythagorean theorem or special triangles to find those values. Well, what we'll find out is that the sine, which is opposite over hypotenuse, ends up being the y coordinate of point A. It's really y over 1. We just wrote right over 1. And that's from opposite over hypotenuse. Cosine is adjacent over hypotenuse, which ends up being x over 1. Now, that's true for any right triangle. It doesn't matter if it's a 45, 45, 90, or a 30, 60, 90, or even one that's not one we're familiar with. This is always going to be true. Tangent is opposite over adjacent, which is y over x. Now, by the way, this is related to the idea of slope. You might remember in Algebra 1 and Algebra 2, even the beginning of this course, we did a little bit with slope. Notice how y's are on top, x's are on the denominator. This is related. It's something that we kind of come across in calculus a bit more, but y is on the top there because that's the opposite. Cosecant, you might remember, is the reciprocal of sine. Since it's the reciprocal of sine, it's hypotenuse over the opposite. So this would be 1 over y. Secant is the adjacent, or is the reciprocal of cosine. So that's the hypotenuse over the adjacent, 1 over x. Cotangent is the reciprocal of tangent, so it's adjacent over opposite, so it's x over y. And so as soon as we know the coordinates of any point, we can find these 6 trig functions, the 3 base trig functions and their reciprocals, just by knowing what x and y are. Now, earlier we have been asking you guys to memorize where the significant angles are, certain angles on the unit circle. And they're all angles that come from either multiples of 30 degrees, 60 degrees, or 45 degrees in either degrees or their corresponding values in radians. So why don't you really quickly stop and see if you can label the angles in both degrees and in radians. And so pause the video while you do that and then restart it and see how you did. This is a skill that you need to have down really, really well to be successful for really this semester, but future semesters as well, and other math classes. So it's a very important topic. You want to put some time into it. Okay, so I have all of the angles down in both degrees and radians for kind of our special values that are the multiples of 30, 45, or 60 degrees. And I kind of color-coded mine. All of the 30-degree angles I've got in purple. The multiples of 45 degrees are in green. 60 degrees are in orange. And then kind of all of my ones right along the axes are blue. So we're now going to take a step beyond this, and instead of just the angles, we're going to now be looking at the coordinates. Now, as we write these coordinates, something I think that is super helpful to understand is that as we write these, for every x, y ordered pair that we write, we are writing the cosine of the angle that has that terminal side and comma the sine of that angle. In that order, the x value is the cosine, the y value is the sine. And then remember, the tangent of that angle could be found by doing y over x, which would end up essentially being the opposite over the adjacent. Now, I'm not going to draw every single triangle, but I'm going to draw a couple so that you can kind of see what's happening. So let's say we just look at this 30-degree angle. We actually, earlier in exploration B, found the coordinates of this point. And what we found out, it was root 3 over 2, comma 1/2. Root 3 over 2, comma 1/2. Now what we're going to find out is that every one of my purple angles that are all these multiples of 30 degrees, they are all actually going to have these same coordinates, but with different signs because of the different quadrants that they are in. But all of these ones that are just the 30 degrees away from the x-axis are all going to have a root 3 over 2, comma 1/2. And that's because they're all could be formed by dropping in and creating a 30, 60, 90 triangle with the x-axis. So you end up with these same values over and over and over again, but with just different signs. In quadrant 2, a 30, 60, 90 triangle would have to start with a negative because we moved to the left. So the coordinates here for cosine and then sine would be negative root 3 over 2, 1/2. For 7 pi over 6, this would be negative root 3 over 2 and negative 1/2. Those are both going to be negative in the third quadrant. And then for this one, in the fourth quadrant, we've moved to the right, but down. So we'll have a positive for the cosine and a negative for the sine. For the 45, 45, 90 angle, or for that 45 degree one, we could draw in an isosceles right triangle, a 45, 45, 90 triangle. Like we did in exploration, I think it was B, I don't remember. But what we found out, maybe it was C, was that the coordinates here were root 2 over 2, comma root 2 over 2. Both the sine and the cosine are root 2 over 2. For every single one that's these green angles, these pi over 4 angles, or these 45 degree angles, multiples of them. So this would be negative root 2 over 2, comma root 2 over 2. This one in the third quadrant, both of them are going to be negative. So both sine and cosine are negative. Cosine first and then sine. If you forget which one comes first, it's in alphabetical order. Cosine, the letter C, starts before the letter S for sine. And then in the fourth quadrant, we have a positive for cosine and a negative for sine. Oops, I wrote the wrong values. For our orange ones, oh, so that was all of the green. So all 4 of those use root 2 over 2, comma root 2 over 2. The signs are determined by the quadrant they fall in. For a 60 degree angle, it's also a 30, 60, 90 triangle. It's just a 30, 60, 90 triangle that has the 60 down here to form that terminal ray. And so what ends up happening is the sine and the cosine are switched because these are complementary angles. So this would be 1/2 and then root 3 over 2. And that's true for all of these orange ones that are closest to the y-axis. Just think about the signs for the quadrants. That's a comma. And then finally, the ones that are on the axes. Keep in mind that this is a unit circle. The radius is 1. So we moved to the right 1 and not up at all. So for the 0 degree angle or the 0 radian angle, it's 1, 0, cosine coming first. At pi over 2, we didn't move right or left, but we did move up 1 unit. So again, these are all using zeros and ones. We just have to think a little bit more carefully on these ones right here because of the fact that the zeros and ones switch positions along these axes, and we have to think about the direction. So this went to the left one and not up at all. And then this one did not move right or left, but moved down 1. So all of these blue have a 0 or a 1. Be careful with those. In some ways they're the easiest, and in some ways they're the hardest. It's just kind of an interesting way to think about it. And then again, all of these orange ones all use the same values, just with different signs. Now, you're going to need to know all of these. In fact, you actually have quizzes on them. And on your test, it would be impossible to be successful on your unit test without knowing these very, very well. So there are some things that we can do to kind of help give you some strategies for memorizing them. The first strategy that I would use is to really memorize the first quadrant. If you know the first quadrant, you can then just reflect things and change signs to find all of the other quadrants. So really, you've got to know these, and then you can figure out the other ones. Hopefully you've already memorized the angles, and that way you're kind of partly done, and now you're just memorizing the cosine and sine values. Now, what we can find is that there is also a numerical pattern. With cosine, starting at kind of the bottom, cosine goes, if I kind of ignore the zeros, I'm just going to look at the 3 in the interior. Cosine's going to go 3, 2, 1 from the x-axis. What is this 3, 2, 1? This is the numerator. 3, 2, and 1. From the x-axis, it's always that order 3, 2, and 1. They're all square roots. The square root of 1 just simplifies. And then they're all over 2, every single one of them. Sine, which is our y-coordinate, from the x-axis, goes 1, 2, 3. On the numerator, 1, 2, and 3. Now that's true no matter which quadrant you're looking at. No matter which quadrant you're looking at, let's say we look at the 4th quadrant. Starting at the x-axis with cosine, we'll go 3, 2, 1, and sine will go 1, 2, and 3. All of them are over 2. All of them have square roots, but the square root of 1 is 1. And then you have to think about the quadrant you're in to determine positives and negatives. So you really want to use this first quadrant. Again, we will use 3, 2, and 1 for cosine. All of these over 2, and all of them square rooted. And so again, cosine comes first, and then sine. And for sine, we'll do 1, 2, and 3. All over 2, and all of them are square rooted. And then the angles would go 30 degrees, which is the same as pi over 6, 45 degrees, which is the same as pi over 4, and 60 degrees, which is the same as pi over 3. You might notice the 30 and the 60 in the degrees versus the radians. We toggle between a 3 and a 6. Kind of watch that. 30 degrees, but yet pi over 6. Remember, this one is 0 degrees or 0 radians. And this is the ordered pair 1, 0. And then this would be 90 degrees or pi over 2. And this one is 0, 1. And if you just think about plotting something with a radius of 1, I think you'll be able to get those. And then once you've got that first quadrant, you can go ahead and then reflect things to get all of the other quadrants. But this one, if you memorize this one, you're going to be in a pretty good place. Okay, so once you know the unit circle, you can find any of these by just looking at the unit circle values. So as a reminder, anytime we're looking at cosine of an angle, we're looking at the x-coordinate. Anytime we're looking at the sine of an angle, we're looking at the y-coordinate. If we're asked for tangent, that is y over x. And then we could do the reciprocal trig functions as well. And so to use this, if I want the cosine of pi over 6, I can go to the pi over 6 angle. Cosine is the x coordinate. And so that would be root 3 over 2. I guess I could have looked above at my first quadrant here. Some of these are in the first quadrant. Sine of pi over 4 would be the y coordinate for the pi over 4 angle, which is root 2 over 2. And notice these ones you cannot use a calculator. Sine of 5 pi over 6. Now, we could go back and look at our full one, or we could recognize that all of our pi over 6 angles are going to use these. And where's 5 pi over 6? Well, 5 pi over 6 is a little bit less than 1 pi, so it's going to be in the second quadrant. And in this quadrant, we're going to be a negative and then a positive. So I want the sine, which is the 1/2, and it would remain positive. Or you could go back and look at your full unit circle. Right here, 5 pi over 6. Sine is the y coordinate. Tangent of pi over 2. Tangent of pi over 2. Tangent, here's your pi over 2, would be y over x. Well, we are actually not allowed to divide by a 0, so we're going to say this is an undefined value. Cosecant, you might remember, is the reciprocal of sine. It's the reciprocal of sine. So 8 pi over 3 is a pi over 3 angle. And anytime you're using a pi over 3 angle, including with the 8, you're going to be using these numbers. Now, since we're talking about sine, we're going to be using the height, the y value. But I have to think about where would 8 pi over 3 be? Where would 8 pi over 3 be? This gets a little bit tricky here because 8 pi over 3 is more than 2 pi. In fact, if I want to kind of see where this would be, 8 pi over 3, let's remove 2 pi from that to find a coterminal angle, and I end up with 2 pi over 3. Well, 2 pi over 3 is here in the second quadrant, and in that quadrant, sine is positive. So this is going to be 1 over root 3 over 2. Which means 2 over root 3, which when I rationalize this would be 2 root 3 over 3. So that one is tricky. As soon as they get over 2 pi, you do need to subtract 2 pi or 360 so that you can find a coterminal angle. Secant of 7 pi over 6. Well, 7 pi over 6 is a little bit more than 1 pi. This is where 7 pi over 6 is. It is a pi over 6 angle. Secant is the reciprocal of cosine. So for a pi over 6 angle, cosine is root 3 over 2. But in this quadrant, they're both negative. So I'm going to do the reciprocal of negative root 3 over 2, which is 2 over negative root 3. I'll just put the negative out front, and then I will rationalize that. Negative 2 root 3 over 3. Cotangent of pi over 4 is the reciprocal of the tangent. Or we could think of it as x over y instead of y over x. Now it's a pi over 4 angle, so we will be using the ratios from pi over 4. 5 pi over 4, if we think about where that is, and I tend to draw a lot of sketches. Again, here's pi, which would be 4 pi over 4. 5 pi over 4 would be here. And in 5 pi over 4, both the x and the y will be negative. And for root 2 over 2, or for 5 pi over 4 and any pi over 4, they're root 2 over 2. This would be the negative x value over the negative y value. Well, we're dividing by the same thing, so we get a 1. Sine of pi. Pi is this quadrant. We move to the left one and over nothing. Sine is the y value, which is 0. Secant of 3 pi over 2. 3 pi over 2 is here. The coordinates for 3 pi over 2 would be 0, negative 1. And we want the reciprocal of the cosine. So this is 1 over the cosine. The cosine on this one is 0. So this is 1 over 0. We cannot divide by a 0, so this is undefined. Cosine of 2 pi. 2 pi is right here. which has the coordinates 1, 0. Cosine is the x value. Cotangent of 0. Tangent, remember, is y over x, so cotangent is x over y. Let me see if I can fix this. So this would be x over y for 0, which is the same as 2 pi. So this would be 1 over 0, and we have another undefined. The secant of, oh, by the way, 0 on the top, 0 over 1 is 0. 1 over 0 is undefined. Just FYI. Okay, secant of 11 pi over 3. This kind of reminds me of number 5, in that 11 pi over 3 is more than 2 pi. So I'm going to go ahead and remove from 11 pi over 3. I'm going to remove 6 pi over 3 to find a coterminal angle, and I'm going to get 5 pi over 3. 5 pi over 3 is more than a full pi over 3. This would be 3 pi over 3, or 1. This would be 4 pi over 3. 5 pi over 3 is here. Now, all pi over 3 angles are going to be like my green one here, 1/2 root 3 over 2. And in this quadrant, the y values are negative. I want the secant, which is the reciprocal of the cosine. So I would want 1 over 1/2, which is 2 over 1, or just 2. Cosecant of pi over 6. This is the reciprocal of the sine of pi over 6. So if I use sine, remember sine is the y value. For pi over 6, we're looking at this 1/2. In that quadrant, everything is positive, but it's the reciprocal of 1/2. So my answer would be 2. Secant of 3 pi over 4. So this would be 1 pi over 4, 2 pi over 4, 3 pi over 4 is right here. In this quadrant, my values are negative and then positive. And these are root 2 over 2s. All pi over 4 are going to be root 2 over 2 for both x and y. I want the reciprocal of the cosine of 3 pi over 4. So this is 1 over negative root 2 over 2. So this is 2 over root 2 as a negative. When I rationalize this, there's some simplifying here. This would be negative 2 root 2 over 2, which is negative root 2. Last one, the cotangent of pi over 3. Cotangent is x over y instead of y over x. Pi over 3, if we think about it as 3, 2, 1, x is the 1 or the 1/2. And then sine or the y would be 1, 2, 3, which is root 3 over 2. So this would be 1/2 and root 3 over 2. Now the 2's here divide out, and I get 1 over root 3 that needs to be rationalized to root 3 over 3. Okay, let's take a look at this again. Find all the values, find the value of all 6 trig functions with the given information about a point or an angle on the unit circle. So here's what we're told. We are going to be told where a point is. We want to find the sine, cosine, tangent, and the reciprocals of this angle. That's at point P. Okay, so first of all, I'd like you to notice on number 16 that both values are positive. Since both values are positive, what this tells me is I'm in the first quadrant. So for my unit circle, that is such a bad circle. Point P is going to be in the first quadrant. And it is at root 3 over 2, 1/2. Now, technically, I don't even need to know which angle I'm working with in order to do this. You might recognize this, that this is a 30-degree angle or pi over 6. It actually doesn't matter because remember the cosine of this angle, which I don't know what the angle is. Well, I can actually find that out as 30 or pi over 6, but this cosine is the x coordinate. The sine of this angle is the y coordinate. The tangent of this angle is y over x. And that rationalizes out to root 3 over 3. The secant, which I'll just go kind of the same order as I started off. The secant is the reciprocal of cosine. So it would be the 2 over root 3, which rationalizes to 2 root 3 over 3. The cosecant is the reciprocal of sine, which would be 2. And the tangent, the cotangent would be the reciprocal of tangent. So instead of y over x, I'll do x over y. And I get root 3 over 1, which is root 3. Now, on number 17, they gave us the angle instead of the coordinates. Same idea, but this time we have to provide the coordinates. This is an angle that we should become very familiar with. If theta is at pi, then the coordinates here are 1, 0. Oops, sorry, we went to the left. Negative 1, 0. So cosine of this angle, we could put pi or theta, whatever you'd like. Those are equal. Would be the x coordinate. Sine is the y coordinate. Tangent is going to be y over x, which is 0. And then the secant is the reciprocal of cosine. So 1 over negative 1 is negative 1. And the cosecant is the reciprocal of the sine, but we are not allowed to divide by a negative, so that'll be undefined. And then the cotangent is x over y, or the reciprocal of tangent, which also has a 0 on the denominator and is also undefined. Number 18. Now these ones are not any of the ones we've just spent like a lot of time talking about from the unit circle. So this is a totally different angle. I don't actually know what angle would form these coordinates on the unit circle unless I use a calculator, which I'm not going to use. So, however, I can know a little bit. I do know what quadrant this is in. I know that I'm going to the left and up. So I'm somewhere in the second quadrant. And I have the x and y values, which means once I know those values, I can find out all of the 6 trig functions. Cosine will be the x value. Sine is the y value. Tangent is y over x. So a little bit of reducing here. Please put the negative either out front or on the numerator rather than leaving it on the denominator. The secant is the reciprocal of the cosine. Again, the negative should be out front or on the numerator. The cosecant is the reciprocal of sine. And the cotangent is the reciprocal of the tangent. Since this is already simplified and it doesn't have any radicals, it's easy for me to just flip that. For this next part, there's just some space for you to use to practice filling out the unit circle, including the x and y coordinates for all of the angles in both degrees and radians. You actually have a quiz on this next class. So you should take a little bit of time, try to fill it out, and then compare it to what we did on page 12 and make sure you can get those values. You might have to put a little bit of time into this before next class. And that is the end of this video.